What if one small pond could feed you for decades? Not once, not seasonally, but continuously. Fish, eggs, aquatic plants, all from a single system that largely runs itself. No feed trucks, no chemical fertilizers, no constant external inputs. Just biology. It sounds unrealistic, but over 2,400 years ago, this system already existed. It was documented as early as 475 BC by Fan Li, and later refined during the Tang dynasty. It wasn't theory. It was practiced at scale. In fact, properly designed pond polyculture systems have been recorded to produce extraordinary protein yields per square foot, rivaling or exceeding many forms of land-based livestock. And yet, most modern households have never heard of it. Why? Because it doesn't fit how modern agriculture makes money. This isn't industrial, it's independent, and that changes everything. The origin wasn't a master plan, it was observation. In ancient China, seasonal floods were common. When floodwaters receded, fish were often left behind in shallow ponds. Farmers noticed something strange. Those ponds became extremely productive. Fish grew quickly. Water remained balanced. Food seemed abundant. But the real breakthrough came later. During the Tang dynasty, carp farming became culturally and politically complicated. Certain carp species were restricted because their name resembled the imperial family name. So farmers adapted. Instead of raising one species, they raised multiple species together. Surface feeders, midwater feeders, bottom feeders, silver carp, grass carp, black carp, bighead carp. Each fish occupied a different niche. Instead of competing, they utilized different resources. And suddenly, the pond became more efficient, more stable, more productive. This wasn't monoculture. This was polyculture. And it changed aquaculture forever. This wasn't just fish farming. It was systems engineering, thousands of years before the word existed. Here's what made it powerful. Nothing was isolated. Waste wasn't removed. It was recycled. Fish waste fed algae. Algae fed other fish. Sediment fed plants. Plants filtered water. Water supported fish. It was a closed nutrient loop. Output became input. Every layer strengthened the next. Contrast that with modern decorative ponds. Clear water, a few ornamental fish, filtration, pumps, zero production. The biological engine was removed. Efficiency was replaced with aesthetics. The original intelligence forgotten. In the 20th century, researchers began re-examining traditional polyculture systems. One of the key figures was H.S. Swingle at Auburn University. In controlled studies, small ponds, around 1,000 square feet, were capable of producing hundreds of pounds of fish per year under optimized polyculture conditions. Not with massive industrial feed inputs, but through ecological balance. These findings validated something ancient farmers already knew. If you design with trophic layers in mind, you multiply output without multiplying resources. Yet, despite scientific backing, this model never became dominant in the West. Why? Because it doesn't centralize production. It decentralizes it. It empowers small landowners. And decentralization rarely scales profitably for large institutions. Now, let's dissect the infinite loop. Not infinite in magic. Infinite in regenerative logic. Ducks, nutrient drivers. Ducks swim constantly. They stir sediment, prevent stagnation, and fertilize naturally. Breeds like the khaki Campbell are especially valuable. High egg production, hardy, active foragers. Their waste introduces nitrogen and phosphorus into the system, which feeds algae and microorganisms, which feed fish, aquatic plants, stabilizes plants, other filters. duckweed, water lilies, cattails. They absorb excess nutrients, provide oxygen, shade the water, prevent algal overgrowth. They prevent collapse. Fish multi-layered harvest. Different fish species consume different food sources. Bluegill, channel catfish, carp species, surface insects, midwater plankton, bottom detritus. Every layer gets used. No wasted energy. Microbial engine, the invisible workforce. Bacteria break down waste. Convert ammonia to nitrites, nitrites to nitrates. Plants absorb nitrates, water clears, cycle continues. Waste gives nutrient, gives growth, gives food, gives waste. That's the loop. No chemical fertilizer, no external feed dependency beyond initial balancing. Just ecological cycling. Now, let's make this practical. You don't need acres. A 10 by 15 foot pond, 4 to 5 feet deep. That's enough to begin. Step 1. Location: partial sun, some wind protection. Avoid heavy leaf fall zones. Step 2. Structurally lined, if natural soil allows. Otherwise, pond liner. Depth matters for thermal stability. Step 3. Water stabilization. Fill, wait. Allow microbial life to establish. Patience here determines long-term stability. Step 4. Plant first, plants first. Let them anchor nutrients. Step 5. Introduce ducks, lightly, start small. Too many, too fast, destabilizes balance. Step 6. Add fish, gradually layer species. Never overload at once. This isn't a tank, it's an ecosystem. This is not overnight. Ducks lay eggs within months. Fish harvestable in 1 to 2 years, depending on species. Plants multiply rapidly. But, unlike annual crops, this system strengthens over time. Biology compounds. The older it gets, the more stable it becomes. Regulations vary. Some fish species require permits. Always check local wildlife laws. In colder climates, depth protects fish. Simple aeration prevents oxygen collapse. Ducks need shelter, not luxury. This is adaptable, not fragile. This isn't nostalgia. It's strategy. Modern food systems depend on feed, supply chains, fuel, distribution networks. This system depends on sunlight, water, biology. Once running, it reduces dependency. Not fully independent overnight, but directionally powerful. And that's the real value. For thousands of years, humans tried to dominate nature, but the most productive systems were cooperative ones. This 2,400-year-old method proves something simple. The best systems don't fight biology. They design with it. And when you align with natural cycles, food stops being a constant external purchase and becomes something that grows continuously. Not infinite by magic, infinite by design.